There are a variety of basic kinds of functions we run into in mathematics, and it's useful to have names to refer to the categories of functions we run into. So for example, a power function looks like this. It's a constant multiplying a variable raised to another constant. So the only variable in this formula is x. A and b are both constant numbers, as we'll see in a few examples. So this is x raised to a power, and that's why it gets the name power function. And for example, 3x squared is a power function. It has this form. The a is 3, and the b is 2. And if you plug 3 in for a and 2 in for b into this formula, this is exactly what you get. So 3x squared is an example of a power function. Another example is t to the fourth. So notice that the variable does not have to be an x. You can use other letters for variables too. Now this at first might look like it's the wrong shape because it looks like you're missing a coefficient in front, but in fact you can imagine a hidden number 1 there, so really the coefficient is 1. And then the power is 4. So this is another example of a power function. This function, square root of x, doesn't look like it's the right thing at first, but it turns out you can rewrite it in the right form, because a square root is the same as a 1/2 power. So if your power is 1/2, and if you again see a hidden coefficient of 1 out front, then x to the 1/2 is a power function. And so square root of x, which is the same thing, is also a power function. Now here's something that's also a power function. 2.7 divided by x. That also looks like the wrong form. But remember that a reciprocal can be represented as a negative exponent. So 2.7 over x is the same thing as 2.7 times x to the negative 1. And we can see it's got the right form with a coefficient of 2.7 and a power of negative 1. This is also a power function. But something like 5 times e to the x is not a power function. It has the wrong form. Why is it the wrong form? Well, notice that the exponent here, in a power function, that's supposed to be a constant. And here, it's a variable. And the base in a power function is supposed to be a variable, but this time it's a constant. E is a number, it's not a variable. So this has the wrong shape. For a power function, the variable is in the base, not the exponent. This is not a power function. You might recall that we actually gave it a different name elsewhere in the course. This is called an exponential function. And be careful not to confuse those. Those terms mean different things. Power function and exponential function refer to different types of functions. 5e to the x is exponential, not power. Alright, now if you combine some power functions together by adding them together or subtracting them, you get a polynomial function. Here are some examples. 3x squared minus 4x, that's a polynomial because 3x squared is a power function and minus 4x is a power function. You might not think of it as a power function at first until you remember that you can think of there as being a hidden exponent of 1 on that x. So these are both power functions, and that means that when you add them together, you get a polynomial. 4x plus 5 is also a polynomial. 4x is the same as 4x to the 1, so that's a power function. 5, you can think of that as the same as 5x to the 0, because raising something to the 0 just gives you 1. So 5 is the same as 5 times 1, so it's the same as 5 times x to the 0, and this is also a power function. So we have a power function plus a power function, that's a polynomial. S plus 3 quantity squared is also a polynomial. You can write it in a different form. If you expand this, S plus 3 squared means S plus 3 times S plus 3. And if you expand this out, you get S times S, that's S squared, S times 3, that's 3S, another S times 3, that's where 6S comes from, and 3 times 3 is where 9 comes from. So now we have a power function plus a power function plus a power function. That's a polynomial function. Next, here are some things that are not polynomial functions. This is a power function plus a power function, but if you go back to the previous slide, you'll see we said it's a polynomial is a sum of power functions with non-negative integers for the powers. And here, although you could rewrite 1 over x as a power function, the exponent's negative, and that's a power function, but it cannot be used to make a polynomial. Polynomials can only have exponents that are not negative. Furthermore, the exponents have to be whole numbers, not fractions. So the square root of t is t to the 1/2, but that exponent is not an integer, not a whole number. So square root of t, although it's a power function, cannot be used to make a polynomial. And finally, 3e to the x minus x to the 4th is not a polynomial because 3e to the x isn't a power function at all. Remember, it's an exponential function. One more important type of function we run into is a rational function. So a rational function is a ratio, that's where it gets its name, ratio, of polynomials. And ratio means the result of division. So one polynomial divided by another polynomial. Here's an example. The numerator is a polynomial, the denominator is a polynomial. That makes this a rational function. 1 over s is also a rational function. The numerator 1 is a power function. You can think of it as 1x to the 0. 0 is not negative, so the numerator is a non-negative power function. That makes it a polynomial. The denominator, which is s, is the same as s to the 1. That's a power function. So the numerator and denominator are both power functions with non-negative exponents, so they're both polynomials. That means the numerator and denominator are both polynomials. That makes this a rational function. And then here's another thing you can rewrite. X squared times x plus 1 to the minus 1. Remember, a negative exponent can be interpreted as a reciprocal. So this is also x squared over x plus 1, which is a polynomial divided by a polynomial. That makes this a rational function. Here's something that's not a rational function because the numerator is not a polynomial. Same thing with this example. This time the denominator is not a polynomial. Therefore, m of x is not a rational function.